Hello, dear friends. Welcome to your PMKVY IoT Developer course, Module 1. I am Professor S.B. Baste, who will be teaching you the first module of this course. So first, let us see how your course is structured. So you have 6 modules in all. The first module is identification and troubleshooting of basic electronic components. Second one is conceptualizing IoT platform and using Arduino. Third one is conceptualizing IoT-based use cases. Next is fundamentals of wireless IoT using Node MCU. The next one is conceptualizing single board computer as an IoT platform using Raspberry Pi. And the last one is a non-technical module, that is employability skills, which will enable you to get employment after the execution of this course. Next one is the examination structure for the first module. It is only for the module 1. So the module 1 is divided into 3 parts. The first 2 parts have 10 marks of theory. The last part has 8 marks of theory, and practical is also divided accordingly. So in all, for the module 1, you have 28 marks of theory examination and 14 marks of practical. So moving on to module 1, that is identification of basic electronic components. Let us first understand what are the basic terminologies which are used in electronics. So the very first thing is voltage. Now voltage is the potential difference between 2 points. So potential refers to the capability of a person of completing a task. The practical unit of potential difference is called as voltage. Okay, so potential difference refers to the difference between the potential of 2 points, and the unit in which potential difference is measured is called as volt. 1 volt is a measure of amount of work required to move 1 coulomb of charge. So you have studied charge and the unit of charge is 1 coulomb. So to move 1 coulomb of charge, if you measure it, it is 1 volt. So this is voltage. The second term is current. When a charge is forced to move from 1 because of the potential difference, the current is produced. Okay, so in conductors, free electrons can be forced to move with a relative ease since they require little work to be moved, because in conductors electrons can move freely because it conducts charge, as we see. So current is the charge in motion. The more electrons in motion, the greater will be the current, right? The next term is ampere. So as we have seen current indicates the intensity of the electricity in motion. The symbol of current for intensity and is measured in ampere. Okay, so current, the unit of current is ampere. The definition of current is I is equal to Q upon T, where I is the current in amperes, Q is charge in coulombs, and T is time in seconds. So charge per time is defined as unit of current, that is amperes. The next term is closed circuit. So there are 2 things, a closed circuit and an open circuit. In applications which require the use of current and electrical components, they are arranged in a form of a circuit. And if the circuit completes a path as shown here, there is a battery, there is a bulb, so there is a closed path. That's why it is called as a closed circuit. Similarly, we have open circuit. So in open circuit, current can only exist when there is a conductive path in the circuit. So you can see here, there are 2 open parts, they are not connected. Hence, the current cannot flow from this part, and hence it is called as an open circuit. Direction of electron flow. So the direction of electron flow in any circuit is from negative side of the battery through the load, resistance back to the positive side of the battery. That means the second part is direction of conventional current. Conventional current flows from the positive side of the battery through the load resistance and back to the negative side of the battery. So if you can see, the flow of electron is opposite to the flow of current. Direct current and alternating current. So the direct current are the currents that are powered by battery sources and termed as direct current. So it is the flow of charges in just one direction. And for alternating current, the voltage source periodically alternates from positive to negative, that it changes its polarity between time. So the resulting current is also having different polarity at different times. That is called as an alternating current. It is similar to our AC source and DC source. Next is basically what is an electronic component. Okay, so an electronic component is the elements of the circuit which helps in functioning the electrical circuit. So these are the basic building blocks of any electronic circuit which helps in functioning of that circuit. They can control the flow of electrons in any electronic system or electronic circuit. These components may consist of two or more terminals. When a group of electronic components is connected together in an electronic board, which is also called as a printed circuit board, a useful electronic circuit is formed. Every component in this electronic circuit will perform a particular task which they are having specific usage. These electronic components can be further classified into active and passive devices, or active and passive components. So the classification of electronic components is as shown in the figure. So they can be classified into passive components and active components. Active components then again will be classified into tube devices and semiconductor devices, and semiconductor devices can be classified into diodes and transistors. So one by one we are going to see all these type of devices and components which are used in electronics. Okay, so first we'll start with the definition of active components and passive components. So active components and passive components can be differentiated using what power source they use. So passive components are the devices which do not need any external power source to operate. Okay, they mainly resist, store, or control the flow of electronic current or voltage in the circuit without actively amplifying or generating the signals. So what they do is they do not need any external excitation for performing their task, and the tasks they perform are to resist, store, and control the flow of electronic current. So the examples are resistors, capacitors, and inductors. These are the most commonly used passive components in electronics. The next is, what is the definition of an active component then? So active components are the electronic devices which needs an external excitation or external power to work. They can actively control and manipulate the flow of electronic current in a circuit. So the classification of active components, as we have already seen, diodes, transistors, integrated circuits, electronic tube, semiconductor devices. So these are what the types of active components which requires external power source. So the basic difference between an active component and a passive component is the type of power source it's required. So if it requires an external power source, then it is an active component, and if it does not require an external power source, then it is a passive component. So let us first see what are the different types of passive components. So for the first type of passive component is a resistor, which is a two-terminal device, and it is used to oppose or limit the flow of current. So it basically works on Ohm's law, which states that voltage applied across the terminal of a resistor is directly proportional to the current flowing through it. Okay, so whatever voltage is applied across the terminal of a resistor, right, so that voltage is directly proportional to the current flowing through that resistor. So the unit of resistance is ohms, and the Ohm's law states V is equal to IR, that is voltage is equal to current into the value of the resistance. So as you see in the picture, this is the resistance which is commonly used, and these colors will indicate the value of the resistance. In the coming lectures, we'll also see how to calculate the value of the resistance using the color bands. Okay, and these are the two symbols which are used in our electronic circuits. When we draw an electronic circuit, we use these type of symbols to represent a resistor. Okay, so resistors are again of two types: fixed resistors and variable resistors. So as their name indicates, fixed resistors are the resistors whose value is fixed. So whenever we insert these resistors in any circuit, we know how much resistance this resistor is going to provide. Okay, so the type of resistor is used to set the right conditions in an electronic circuit. The value of resistance in fixed resistors are determined during the design phase of the circuit. Based on this, there is no need to adjust the circuit. So the value of this resistor is fixed in the beginning. Variable resistors are the resistors whose value we can change according to the requirement in our electrical circuit. So it has a minimum value and a maximum value, and we can change this value of resistance accordingly between its minimum value and a maximum value. This, sorry, these resistors comprise a fixed resistor element and a slider that taps on the resistor element. So variable resistors are commonly used as a three-terminal device for calibration of the device. So fixed resistors are two terminals and three variable resistors are three terminal. Next is capacitor. So a capacitor is made from two conductive plates with an insulator in between, and it stores electrical energy in the form of an electric field. A capacitor blocks the DC signals and allows the AC signals, and also used with a resistor in a timing circuit. So basically, a capacitor is a component which stores electric energy in the form of an electrical, in the form of an electric field. Okay. The stored charge is given by Q, which is equal to C into V. Okay. The capacitance is defined, or as we see that there is a resistor and resistor provides resistance. Similarly, element is a capacitor and it provides capacitance. So the capacitance is the amount of energy which is stored in that capacitor. Okay, so higher the capacitance, the more is the energy it can store. You can increase the capacitance by moving the plates of the capacitor closer to each other or increasing the size of the capacitor. Okay, so as shown in this image, you can see this is called as a disk capacitor, this is called as an electrolyte capacitor, and the symbol which we use while drawing the circuit is like this, which we use for ceramic capacitor and your electrolytic capacitor. The third type of passive component is called as an inductor. Inductor stores and release magnetic energy. It is referred to as an AC resistor. So the first resistor which we used or which we have seen was also called as a DC resistor. Inductor is called as an AC resistor, which stores electrical energy in the form of a magnetic energy. It resists the change in current, and the standard unit of inductance is Henry. The capability of producing magnetic lines is referred to as inductance. The equation for the inductance is given in the slide. Mu into K into N2 into S divided by I, where L is equal to the inductance, mu is the magnetic permeability, K is the magnetic coefficient, S is the cross-sectional area of the coil, N is the number of turns of the coil, and I is the length of the coil in the axial direction. Okay, so whenever the current passes through a wire, it creates a magnetic field. However, when the unique shape of the inductor leads to the creation of much stronger magnetic field, and this powerful magnetic field in turn resists the alternating current, but it lets direct current flow through it. So it will oppose the alternating current, but it will allow the direct current to flow through it. This is how the magnetic field stores the energy. Inductors can be further classified into air core, iron core, and ferrite core components that we'll see in the coming lectures. Okay, so the summary of today's lecture is we have studied the basic terminologies which are used in electronics, basic electronics. Then we have seen how these electronic components are classified. what is the definition of active and passive components, and what are the different passive components that are used in electronic circuits, that are resistors, capacitors, and inductors. In the next lecture, we'll see the classification of active components. Okay, so thank you.